Hello friends, today we are going to design footing for our G plus 11 story building. As we have already completed our series for recap, now we are starting for footing design in shape. For this, you have to first analyze your model and then export F2K file. For this, go to export. Here is the option shape.f2k file. Click on this. Select story to export, base story. Loads to export for loads and loads from above. For load cases and combinations, select all load cases and combination you can define also in safe. So I have already selected. Okay, now save the file. Now the exporting is completed. Now go to save. In save, open save application and go to file import import.f2k file. Here is our file. Click on open. Now you can see your grid is imported. The point is invisible, so you have to first make points visible. As you can see, the support points. Now I'm going to hide the grid. So go to modify grid. Here is showing duplicate ordinates, so you have to delete all the duplicate ordinates. I'm starting one by one. Just select and duplicate. These are only grid ordinates, so you can delete them directly. Click on hide all grid lines. Click on OK. OK. Now you can only see the points, base points. So just click on, right click on a point. You can check loads. As you can see, all the loads. You can check all the points. Our importing is OK. You can check randomly any point. OK. The importing part is completed. Now we are going to define material property. Add new material M25. I'm taking M25. Change all the values here. Modulus of elasticity for M25 25,000 Newton per mm square, and the compressive strength 25. Click on OK. Add rebar property. For rebar I'm taking FE 500. FY 500. The tensile stress for FE 500 545. Click on OK. I'm also taking FE 415 rebar 415. 485. Click on OK. OK. Now material is defined. Define slab properties. Add new property and give name. Start from 450. Slab material M25. Click on footing, or for in case combine footing you can select mat. I am selecting footing 450. Click on OK. I'm deleting this. Add copy of material. Define different types of depth, so you can easily change while analyzing or iterating the model. So define number of depths. I'm just taking few depths. Click on OK. 600. Last one I'm taking 750. If you need more depth of footing, you can define later on. So I'm just taking these four values. Now you have to define stiff member. For this, take depth of stiff as the same as you have defined the footing depth. For this, you have to click on stiff here, and here we define one stiff member. So for each depth of footing, you have to define different stiff members. Define 500, 500. Stiff 600. Stiff 600. Now the last one. Stiff 750. Click on OK. The slab material is defined. Now we have to define soil properties. For soil properties, I'm going to modify the soil properties. I'm giving name as SBC 300. In our case, our SBCC is 30 ton, that is 300 kilonewton per meter square. The soil mod here is the subgrade modulus. The subgrade we have to calculate subgrade modulus for save. For this, the formula for subgrade modulus is SPC divided by settlement. Our SBC is 300 and our settlement we have considered as 20 mm. So 300 divided by 20 mm, 15,000 kilonewton per meter here is cube. This is in kilonewton per meter cube. So 15,000 kilonewton per meter cube. Click on OK. Now go to load patterns. As you can see, all the load cases already imported from the tab. So define load combinations. As you can see, load combinations also imported. If you redefine want to redefine the load combination, you have to just delete all the load combinations and just click on add default load combinations, and you can get new load combinations. As the limited time, we are just taking few footings randomly. I'm selecting these two and these two. This is shear wall and this is column. So we are going to delete all the rest footings, column points. I just kept 4 columns so you can design easily. Now you have to consider footing size for initial drawing. So for that we have to go to our ETAB model. I'm going to base. I'm selecting. We have selected these footings. So just selected object. Now I'm checking reactions for these points. As you can see, here is the reaction. Now we have an Excel sheet for footing design. Now I am taking this value and putting in my Excel sheet. Values 1620 and our column is 300 by 600. So I'm not designing in Excel, I'm just taking the initial footing size. So I can draw this size of footing 1900 and 2200. So first go to, here is the option, you can draw as slab or directly click on this option. Now X direction, as we have calculated X direction 1.9 and Y direction 2.2. So you can select the initial value and then revise it later. So I am selecting 450 and just click on the point. As you can see, the footing will appear. And now we have to add a column strip member. For this, just click on 450 strip and the dimension is column dimension. Give the column dimension for the strip member. Dimension is 0.3, 0.6. In this way, you can, this is column we are taking as a strip member. You can check by extrude views. As you can see, here is the shear wall, the footing. So in this way, you have to draw all these points. For shear wall, you have to draw. Let's draw this for this shear wall so that you can understand. For this, I'm taking the beam line, a null line. I'm taking offset of 600. So take a 600 option and draw a line. Just in this way you can draw the lines. As you can see, I'm drawing a line here. I have drawn I have drawn the footing outline. Now for column we can check the shear wall. You have to take offset shear wall. Our wall is 300 wide, so take offset, one side offset 150. In this way you can draw outline for the column and outline for the footing. Now just click here, option draw slabs, take a footing member, just draw slab. Your footing is ready. Now same way you have to draw steep member. Just click on point. You can check member here. The value is T 450 and F 450. Okay. In this way you can draw all the footings initial level. Now all the footings are modeled, and after modeling part for all the footings we have taken here 4 footings. You can model all the footings, and then we have to assign soil properties. So for that select all the footings and also the steep members. Go to assign support data, soil properties. Here we have defined SPC 300. Click on OK. As you can see, soil SPC 300 is assigned to all the footings. Now we have to run our model. Before this we have to check our load combinations. As we have imported the load combinations from ETAB model, you can define or take default load combinations. So we just check the load combination, default load combination from safe also. For this, first go to design preferences. Yeah, you have to change the code. Select IS456. Click OK. All parts should be OK. Now go to load combinations. First delete all the default combinations, then click on all options. Here are some options: change service initial, service normal, and service long term. So you can check all the options and click on OK. As you can see, you can check each combination. Click on OK. Now we are all set to run the analysis. You can check the deform shapes. Here you can see the load case. So we have to first check one by one. First we are going to check displacement. For displacement we are going to check for Ticon 2. This is our service load case for normal serviceability. So click on OK. You can check displacement. You can check the values. As you can see, the value is showing more than 20, as we have considered our settlement 20 mm. You should limit your value under 20 mm. You can check all the footings. So we have to increase footing size. For this footing, you can see the value is 74 mm. So this is very less value for this footing. You need to increase the value. This will in the near to the 20. So for this footing, if you increase this size of the footing, these two footing will be combined. So we will check combined footings in our next video. Now we will ignore this footing and we will design these three footings. So first we have to increase our size. You can revise size by reshaping. This is option, reshape object. You can reshape it. You can increase by reshaping it, or in case of individual footings you can just draw it again. So I'm going to draw it again. For this footing I'm increasing by 100 mm. We are drawn 1.9, so I'm drawing 2.1 and 2.4. For this footing we are drawn 2.2, 2.4 and 2.8. We are ignoring this footing, so I'm just delete it. We will discuss combined footing in our next video. So for this footing I am taking 600 2 point, sorry 2 point, take 3 and 3.6. Okay, now assign soil properties again and run again. Now we are going to check it again. For first displacement, load combination 2, click on apply. Now check the maximum value for the displacement. As you can see, for this footing displacement is in limit, is less than 20 mm. For this footing it's also less than 20 mm. This is just 20 mm. So for study purpose, we just ignore it, and this is also less than 20 mm. Now we'll check SPC. For this, go to reaction forces, load combination, decontour. Here is option type of reaction. Select soil pressures, put the maximum and minimum values. Minimum, I'm taking minus 300 to 300. Now you can see the value is limiting less than 300 for this footing. It's okay. This footing is also less than 300, and this footing you can check the value is just about 299. So we can go forward as the footing is okay for SBC. Now after this you have to check a footing for punching. So for that you have to run design also for initial stage. Now you can see the option here, show punching shear design. You can check the values. This value should be less than 1 for this footing. This is okay. For these two footings the value exceeding 1, so we have to revise the depth for these two footings. You can change the depth of footing by select the footing, assign, go to slab data, properties, and just click on OK. You have to also change the depth for the steep member also. So click on OK. Both the values are changed. Now for this footing I'm taking higher value. Click on OK. For steep member also, and there is no value, so I'm defining it again. Now both the values you can check here by right clicking. Here you can see the value for the slabs. So run it again. Now you can see the values. It is limiting less than 1, and this is also near about 1, so we are ignoring this. You can check higher value for this. In this way you can check the initial, the settlement check, bearing shear check, bearing pressure check, and punching shear check. Now our footing is ready to design. For design we have to draw design steps. So I'm going to break the model, draw, Here is the option draw design strips. You can see. So take here you can define two layers. So I'm taking first layer A, taking as a column strip, and this footing, the footing length for this footing is 2.4. So I'm dividing 2.4, half of the 2.4, 1.2. So you can see start with left and start with right. When you select the point to draw the strip, the you have to provide one half of the strip width. So I'm taking 1.2, 1.2, 1.2. Now draw the strip. You can see the single line. You can change it from here is option design strip object show width. Click on OK. You can see the width for the strip. Now in another layer for this 1.05, 1.05, 1.05, you can see both the direction I have drawn design steps. Now similarly you can draw for these footings also. For this footing I will read this 2.4. So take 1.2, 1.2, 1.2. Now in A layer and change 1.4, 1.4, 1.4 and 1.4. Similarly for this footing also the width of this footing is 300 by 3000 by 3600. So first for length 1.8, 0.8, 1.8, 1.8. Same for the next P layer 1.5, 1.5, 1.5, 1.5. Okay, so strip drawing is done. As you can see all the footings are done. Now run again. We have checked all the aspects already, so we have to only check the strip data. So here is the option. You can go to display. Here are the option show strip forces, or you can check here show strip forces. For this we have to define envelope or check. For the time being we are checking for this combination also, but we have to for checking forces we have to define envelope. So for layer A, for design you need not to define envelope as it takes enveloping forces itself. For moment readings you have to define enveloping envelope so that you can check the result for envelope. Now I am checking for this combination. Select moment, select layer for which you are checking. Now click on apply, and you can see here is the values. You can see the value for movement. You can see all the footing, the moment values. Now for B value, B layer in this direction also you can check the moment values. Similarly, you can check shear force also. In this way you can check moment and shear force for on the strip basis for the footing. Now we are going to check reinforcement. For this, go to show slab design, or here is the option show slab design. You can check, or you can set all, you have to set all the options. First you have to select strip base. Here you can see enveloping flexural reinforcement layer 1. First we check for layer one by one. So show top rebar and bottom rebar. Here is important option in shape, the reinforcing display type. Show rebar intensity area per unit width. As we have drawn the strip width for whole the footing width, so it will convert area of reinforcement per unit width. And if you select the second option, the total rebar, it will show all the maximum value of the rebar. And the third one is rebar size. It will show you the direct rebar size. Now we'll check the first, show rebar intensity area of unit width. Skill factor, click on apply. As you can see, the value that here is showing the reinforcement per square per meter. In this way you can check the reinforcement for the footing for all the footings. You can also change here the bar size. I am taking 16 dia in both directions. Click on apply. As you can see, it will show number of bars directly. So in this way you can check all the footings for reinforcement. We just check in layer B. As you can see, in this direction also you can check the value. For this reinforcement value you have to provide reinforcement, and the footing design is ready. You have to, you can detail it in shape also, or you can manually draw the or prepare schedule in AutoCAD. Now from these results, the reinforcement result, you can prepare the schedule for the footing reinforcement. So for that you have to go to AutoCAD. As you can see, I have already prepared the foundation layout plan. You can see the foundation layout plan for the same building. In this way you can prepare all the sections, and here is the combined footing section. We will go to see in our upcoming video, and you can prepare the column schedule, footing details in this way. The size of footing and reinforcement. So in our next video we are going to see combined footing, lip footing and shear wall footing. Please subscribe channel and share this video, and stay tuned for next videos. Thank you.